Yes, I did it. After hours of research, I finally made an AI agent which would help me study, instead of actually studying.
Hi, my name is Zubair Hussain, and for the past 2 years, I've been studying in Germany for my master's degree. In this video, I'm going to show you how you can make a RAG agent-like pipeline that can help you study with your study slides. So let's get started. The prerequisites of this project is, of course, the study slides of the course that you're planning to use this AI with.
Keep them in a folder like this.
There are mainly three things that I'm planning to do with this contents of this slide. Firstly, I want to generate a simple concept explanation, a detailed explanation of the concept, as well as generate some quiz question and answers. So here's the entire plan. First, we take one of the slides of the folder. A slide generally talks about a specific topic of the course, but that topic is further broken down into many subtopics. Then we divide the slides into pages. Now comes the hard part. How do we know how many subtopics are in these slides? Like, which subtopics are contained within the pages? Introducing
semantic chunking.
I saw this technique in one of the famous Groq Comrade video where he explained in detail how you can chunk for a RAG pipeline. Check this video out if you find that interesting. I'm using a modified version of that where instead of comparing consecutive sentences, I'm comparing consecutive pages of the slide. Let me explain. I'm making a highly accurate assumption that the topic does not vary within the concept of a single page. So moving on to the next page, there are two possible scenarios. One is that the topic of the previous page is still being continued. Another is that a new topic is started on the next page. The challenge is to classify which is which. So what we do is we get the text of the contents of all of the pages and turn them into separate embedding vectors. Yes, I love using embeddings. Then we get consecutive cosine distances between the pages. Some of the distances will be low, indicating that there are low semantic differences between the pages. The ones that are high are the one we're looking for. But where is the threshold? Groq finds the threshold using different statistical methods such as the percentile, standard deviation, and interquartile range. I'll be using the percentile method to find the threshold in my project. Okay, so let's run through the code fast and then I'll do the explaining. First, we import the necessary modules as shown in here. Next, I use this block of code where I just read through the PDFs or slides in this PDF folder and transfer the text extracted from them into a markdown format so that it can be easily accessed and read by the LLM. In this part, I'm just extracting all of the embeddings from the texts and obviously doing some small stuff where I exclude the pages where the number of text characters is less than 500. And I'm using the nomic embed text model from Ollama to get the embeddings of the text. And I'm storing the embeddings as well as the text in arrays. Here, I'm just calculating the cosine similarity distances between all of the embeddings. Here, I'm using the NumPy percentile to find a breakpoint and using that to produce this graph where I can understand where the topics are talking about far apart subtopics. This is the graph where the cuts are made using the percentile method. And we can see here that the pages between the cuts contain the same subtopics because the semantic meaning between them is very low. Then I cut the text array according to the breakpoints that I have found using the percentile method in this block of code. Now that we are able to isolate all of the subtopics from the graph, now it's time to produce the stuffs. I'm using a Groq API to get free access to Llama models and many others. If you want, you can have a look into Groq Cloud to find all of the models and get its API for free. After getting your Groq API key, you can just easily put it here using the getEnv method. The LLM that I'm using for this model is the Llama 3.3 versatile 70 billion model from Chad Groq. And defining the LLM here, and then I'm producing two different Pydantic classes so that I can get the quizzes in a JSON format. This is the structured output line that I'm using. So I'm using some specific prompts to generate the simple explanation as well as the detailed explanation for the text that are being generated. This is the simplify prompt where I'm creating a simple chain with the simplify prompt as well as the LLM. Here's the explainer prompt, where I'm creating an explainer chain with the explainer prompt as well as the LLM. And finally, this is the quiz prompt, which is going to prompt the LLM to produce quizzes. And here, not only I'm just giving the LLM, but I'm giving the structured LLM so that the response of this prompt comes in a structured manner. And like this, we just invoke these three models with just the same text, and we get three different responses. Here you can see that the input that we gave to the model. This is the starting of the first slide, so there is not much thing about education in here. But as you can see, this is a simplified explanation of the slide. This is the detailed explanation of the slide. And we get quiz questions in this manner. So suppose you're studying for a course and there's a lot to memorize and to learn, and you're just simply not learning anything just by reading the slides. Simply pop those slides into this AI and let the magic unfold. So that's it for this video. In the next video, I will show you how to chat and interact with the slide contents with AI in a very polished and well-structured UI. So subscribe if you don't want to miss that, and I'll see you in the next one.